Hey everyone, in this video we're going to learn how to graph two variable inequalities. In order to do that, we're going to have to combine concepts from graphing lines with concepts from solving and graphing one variable inequalities that we've been doing. Our first example, which of the following points satisfy the inequality 3x minus 4y is less than 24? Now in order to answer that question, we're going to take each point and plug it into the inequality. And we're going to see if we wind up with a true statement or not. So our first point is 0, 0, or the origin. So we're going to plug 0 in for x and 0 in for y. And see if that's less than 24. So we have 0 minus 0, which is 0, is less than 24, which is a true statement. So I'm going to put a box around this point. The point 0, 0 is in the solution set of this inequality. Our next point is 3, negative 4. So again, we're going to plug in. So we're going to substitute 3 in for x and negative 4 in for y and see if that's less than 24. So we have 9 plus 16, which is less than 24. So is 25 less than 24? And that is not a true statement. So that means the point 3, negative 4 is not in the solution set of this inequality. And our last point, negative 1, 2, substitute negative 1 in for x and 2 in for y. And is that less than 24? So we have negative 3 minus 8, which is less than 24. Negative 11 is less than 24, which is a true statement. So the point negative 1, 2 is also in the solution set of the inequality. So to use this method to try to find all of the points that satisfy the inequality would be way too much time and effort, and we wouldn't actually be able to achieve that. But we can represent this solution set graphically to have an idea of all of the points that would satisfy this inequality. Now, how are we going to do that? So to graph an inequality in two variables, we must think about the following. Whether the line is going to be solid or dashed, which will be based on the inequality sign. If we have less than or equal to or greater than or equal to, that's going to be a solid line. We have equality. And if we have strict inequality, less than or greater than, it's going to be a dashed line. So the first thing we're going to do is graph the inequality as if it were a line. Okay, plot the points, get the slope, get a point on the line. That's our first step. And then after we've done that and we've decided whether to connect the points on the line with a solid line or a dashed line, we have to figure out where we're going to shade, where the solution set of the inequality is. So we can either think about it mathematically, or if we're unsure, we could take a point that's not on the line and test the point, just like we did on the last slide. And based on whether we get a true statement or a false statement, that will tell us where we should be shading. So I'll show you both methods as we go through our examples. So first up, graph 3x minus 4y is less than 24, the same inequality that we started with. So first step, we want to just graph the line 3x minus 4y equals 24. Now this is a line in standard form, so to graph it, we're going to first look at the intercepts and see if those are nice points to graph. So the x-intercept, remember that happens when y is 0. So we'd have 3x minus 4 times 0 equals 24. So 3x equals 24, x equals 8. So we have the point 8, 0. And the y-intercept is the point whose x-coordinate is 0. So we'd have 3 times 0 minus 4y equals 24. So negative 4y equals 24, y equals negative 6. Okay, so we'll plot those 2 points, 8, 0, and 0, negative 6. Now the next decision is, are we going to connect these points with a dashed or a solid line? So we have to look at our inequality sign. So we have strict inequality here. So we're going to have a dashed line. And it always helps to write yourself a reminder as you're going through your work. So we're going to connect with a dashed line I want an arrow on both ends here. Okay, so there's our line. I need to fix this side a little bit. There we go. Okay, so there's the line through the points. It's a dashed line. And now we have to figure out where we're going to shade. So this one's not as easy, so let's use a test point. So what I'm going to do is I'm going to take the green marker. Our test point is going to be the origin. Always the simplest. If 0, 0 is not on your line, use that as your test point. So test point is 0, 0. So how do we test it? We plug it into the inequality. So 3 times 0 minus 4 times 0 is less than 24. And I know we've already done this. We have 0 is less than 24, which is a true statement. So that means this point, the origin, is in the solution set, which means our solution set is all points on this side of the line. Okay, so there is the graph of the solution set of the inequality 3x minus 4y is less than 24. Pick any point in this shaded region, in this half plane, and that point is going to make this inequality true. Okay, so now let's look at another example. Y is greater than or equal to 2x plus 1. So in this case, we want to graph the line y equals 2x plus 1 first, which is pretty straightforward. This is in slope-intercept form, so we know the slope is 2, and the y-intercept, or a point on the line, is 0, 1. So we have the point 0, 1, and we have a slope of 2. So there we have points on the line. Next, we have to decide if we're connecting these points with a solid or a dashed line. So looking at our inequality sign, it's greater than or equals to. So that means the points are going to be connected with a solid line. So a solid line, again, I want arrows on both ends. So there's the graph of the line, and now we have to include the rest of the solution set. So are we going to shade above or below the line? So in this case, I'll show two different ways that we can think about this. First is think mathematically. We're looking for where points have a y-coordinate that's greater than or equal to 2x plus 1. Well, any point above the line is going to have a y-coordinate greater than 2x plus 1, because the points where y equals 2x plus 1, those are all the points on the line. So the points whose y-coordinate is greater than 2x plus 1 are above the line. Now, if that didn't make sense, pick a test point. Now 0, 0 is not on the line. I know it's really close, but it's not on the line. Okay, so we can also use a test point, okay, which is 0, 0. So substitute that into the inequality. So we'd have 0 is greater than or equal to 2 times 0 plus 1. So we'd have 0 is greater than or equal to 1, which is not true. So that means that red point should not be in the solution set. And since we already graphed the solution set, we could see that it is in fact not in the solution set of this inequality. Okay, so two different ways. We can either reason it out mathematically, which in this case I think was easier, in the last case would have been a little bit more difficult, or use a test point. And the test point's definitely the tried and true method, right? It's never going to lead you astray, unless you plug the point in wrong. So I should mention that. Make sure you're plugging the x-coordinate into the x variable, y-coordinate into the y variable. Next up, graph y is less than 3 over 4x minus 3. So again, nice. We're going to start by graphing the line y equals 3 over 4x minus 3, which is in slope-intercept form. The slope is 3/4, and a point on the line is 0, -3. And that happens to be the y-intercept. So 0, -3, a slope of 3/4, so up 3 to the right 4, up 3 to the right 4, and then going the other direction, down 3 to the left 4, down 3 to the left 4, and there we have points on the line. Now we have to decide if we're going to connect those points with a solid or a dashed line. So look at our inequality sign. It's less than strict inequality. So we're going to have a dashed line. So I'll use my dashed line, make sure I have an arrow on both sides. So there's our line, and now we have to figure out where our solution set is going to be. Are we going to shade above or below the line? Now, let's first reason out mathematically. Y is less than 3/4x minus 3. Well, all the points on the line are where y equals 3/4x minus 3. So the points whose y-coordinate is less than that value are going to be below the line. So all our points in the solution set are going to be below the line. Again, if we're not sure still, the origin's not on the line, so use it as a test point. So our test point is again the origin. So plugging 0 in for y, we have 0 is less than 3/4 times 0 minus 3. So we have 0 is less than -3, which is not true. And we could see that makes sense. The origin is not in the solution set that we shaded before. Okay, so hopefully you're getting the hang of it, right? But a couple of key ideas. We have to make sure we're good at graphing lines, all that stuff we did previously, because we're building on it. Once we've graphed the points or plotted the points on the line, solid or dashed based on the inequality sign, and then where is our shading? Where is our solution set? Okay, so to connect this to a single variable inequality, think about what we did on a number line, right? If we had x is less than 3 or x is less than or equal to 3, our first decision, should we make an open or a closed point on the number line, right? So that's the same decision as solid or dashed line. And then we had to decide, do we shade the values that are less than 3 or greater than 3? And we're doing the same thing now, but now we're shading on one side of the line, above the line or below the line. Okay, so a lot of similarity to what we were doing on the number line. Now we're just doing it on the xy axes. Graph x plus y is greater than or equal to 5. So first thing we're going to do is graph the line x plus y equals 5, which is in standard form. So we'll find the x and the y-intercept. So the x-intercept is the point whose y-coordinate is 0. So we'd have x plus 0 equals 5, x equals 5. And the y-intercept is the point whose x-coordinate is 0. So 0 plus y equals 5, y equals 5. So 2 points on the line, 5, 0 and 0, 5. So 1, 2, 3, 4, 5, 0, and 1, 2, 3, 4, 0, 5. And all we need is 2 points to graph the line. Now we have to decide how we're going to connect those 2 points. So we look at the inequality sign. We have greater than or equal to. So that means we're going to have a solid line. Right? We have equality here. So solid line. Make sure I have both arrows. So there's our line. And now we have to graph the solution set, or the rest of the points in the solution set. So, in this case, a little bit more difficult to figure out, should we shade above or below. So let's pick that test point, 0, 0. So our test point is the origin. So we have 0 plus 0 is, that's not what I wanted, is greater than or equal to 5. So is 0 greater than or equal to 5? It is not. So that means our solution set is all the points above the line, right? The side of the line that doesn't include the test point, doesn't include the origin. So we shade on the other side. Okay, test point doesn't work. The solution set is on the other side of the line. Test point works, then we shade on that side of the line. So there is our solution set of the inequality. Next up, y plus 1 is greater than negative 2/3 times x minus 6. So we have an equation in point-slope form. So I'm not going to rewrite it this time. Let's just go directly to graphing. So we have a line whose slope is negative 2/3, and a point on the line is 6, negative 1. Let's make that look a little bit neater. 6, negative 1. So we'll plot the point, 1, 2, 3, 4, 5, 6, negative 1, and plot a slope of negative 2, so down 2 to the right 3, in the other direction up 2 to the left 3, 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 and one more point. Now we have to decide if this should be a solid or a dashed line. So strict inequality, greater than sign. So we have a dashed line connecting our points. And now we have to figure out where we are shading. So we're looking for where y plus 1 is going to be greater than negative 2/3 x minus 6. So again, let's just practice using the test point here. So our test point at the origin. So we have 0, 0. Substituting that into the equation, so we have 0 plus 1 is greater than negative 2/3, 0 minus 6. So we have 1 is greater than, so negative 2/3 times negative 6 would be 12 over 3, which is 4. So is 1 greater than 4? It is not. So 0, 0 is not in the solution set. That means we're shading all points above the line. So there we have our solution set of our inequality. Now again, if it's in point-slope form, make sure we're able to pull out the slope and the point. It's going to make graphing these so much more efficient. We're not going to have to spend time simplifying. Maybe we do it incorrectly. Maybe we do it and there's not a nice y-intercept, so we wasted a little bit of our time. Right? We have to be comfortable with our point-slope form of a line. Graph y minus 3 is less than or equal to 4 times the quantity x plus 2. So again, going right into it, we have a line with a slope of 4 and a point of negative 2, positive 3. So plotting the point negative 2, positive 3, and a slope of 4. So up 1, 2, 3, 4 over 1. And we'll go down 4 to the left 1, down 4 to the left 1, down 4 to the left 1. We have to decide if it should be a solid or a dashed line. So we look at our inequality sign. It's going to be a solid line. We have equality here. So a solid line. What happened? Gotta get that back. Okay, so there is our line. And now we have to decide where we should shade. Okay, so in this case, we're looking for where y minus 3 is going to be less than or equal to 4 times x plus 2. Well, all the points on the line are where y minus 3 is equal to 4 times x plus 2. So the points where y minus 3 is going to be less than that is going to be all points below the line. Now I know it looks kind of weird saying below the line, right? It looks more to the right. But remember, this line extends infinitely, so there's an above and a below. If you're not sure, again, check your test point. Right, test point. At 0, 0, substitute it in. 0 minus 3, is that less than or equal to 4 times 0 plus 2? So is negative 3 less than or equal to 8? Which it is, so that point should be in the solution set, and we see it is in fact in the solution set. Last example, go the other direction. Now we're given a graph, write the inequality. So first thing, let's write the equation of the line. So I see that my slope, I go up 1 and over 2, so my slope is 1/2. I don't have a nice y-intercept, so I can pick any point on the line and write in point slope form. So I'll pick this point here, which is 1, -3. So writing the equation in point slope form, I'd have y plus 3. Not going to write equals, I'll leave that blank. 1/2 times x minus 1. If we were writing the equation of a line, that would be equals. We're writing an inequality. So the first thing that I see is that we have a dashed line. So that means we're either going to have less than or greater than. Now looking at the fact that the shading is all below the line, I would say that all these points, the y plus 3 value is going to be less than 1/2 times x minus 1. Again, remember, y plus 3 equals 1/2 times x minus 1 for every point on the line. So the points below it, y plus 3 is going to be less than 1/2 times x minus 1. If you're not sure, another way, use that test point. Use that origin. Right? So we'd have 0 plus 3. We don't know what that is. 1/2, 0 minus 1. So we'd have 3, and then -1/2. Notice that's not in the solution set, so we want this to be false. Okay, so how can we make this false? Well, we could say that 3 is less than -1/2, right? Because that's a false statement, so there's our inequality sign. Okay, so a lot of little nuances here, but a lot of good practice, right? We got practice in graphing lines again, whether it's in standard form, slope-intercept form, or point-slope form. And then we talked about how we're going to represent the solution set. And again, as I mentioned earlier in the video, the first decision is if it's a solid or a dashed line, which is based on the inequality sign. It was the same thing when we were graphing a single variable inequality. Should it be an open point or a closed point? And then on the number line, we had to figure out, should we shade above that point, right? Values that are greater than or values that are less than? Same decision, but now our points are coordinates, x and y, and we have to decide, do we shade above the line or below the line? We can think about that mathematically, or we could pick a test point and plug it into the inequality to check.